All right, so this is just a quick video going over a few different audio and visual settings for when you're doing online lecture recording to try and optimize quality, potentially with just equipment that you have, but maybe with just a minimal additional equipment. So when we're thinking about our lectures, we want to care about how they're perceived and also, how that leads to potentially an increase in comprehension. And I think the quality of the video plays a lot into that. So one thing that people don't realize is that audio quality is actually the single most important factor in both the perception of quality and also the comprehension of your video. And there's a number of studies that have been published to back that up. So of course, the single, biggest factor is how good of an instructor you are and the content you're sharing. But, when we're sharing that through a digital medium, audio quality becomes extremely important. So when we're thinking about audio quality, there's really four main things that play into that: the distance of the microphone to our mouth, the quality of the microphone that we're using, the quality of the equipment that microphone is plugged into and how that's capturing the audio that the microphone's putting out, and then also the environment that you're recording in, the room, the physical space that you're in. So when we're thinking about the distance of the microphone from our mouth, you want it to be as close as you can get it to your mouth without blowing air straight into it, with either your nose, breathing into it or your mouth. So, as your mic is further away, that distance is going to fall off, the volume is going to fall off exponentially. So whatever your recording device is going to increase what's called gain to help compensate for that distance. And that's going to introduce background noise because that sensitivity, comes at a cost. If you're speaking into a professional microphone, then you can use a pop filter so that you can really have your mouth right up into it to get better audio quality without getting what we call plosives, when you get that pop of sound when your breath hits it. So this is called a pop filter. This is this thing I have in front here. All right, so I'm just going to play this quick video here showing the effect of distance on audio quality with just a cheap small microphone. All right, this is checking the audio quality far away from my mouth, showing that there's going to be a lot of background noise and it's going to be echoey. And now it's checking it close to my mouth, showing that it's going to be a much deeper, richer audio quality without background noise, just because it's closer to my mouth, so the noise is much more intense and therefore my gain can be turned down. Audio quality far away, which is absolutely terrible. Audio quality close up, which is high quality. All right, so you can see that how far your microphone away from you makes a difference. So if you're using a built-in microphone from your laptop or something that's far away, the audio quality is going to be low. If you're using some separate microphone that you can get close to your mouth, like a headset or a lavalier microphone, then your audio quality is going to improve. The quality of your microphone does make a difference. So of course, if you spend more, you get more, which is true with most things, and microphones are no exception. But the quality drops off pretty rapidly as you go up in cost. So once you get past $30, $50, or $100, you're really getting into tiny changes in audio quality that are only really for critical listeners. But the thing is that a lot of our students are listening with headphones, and so the fidelity that they're getting is much higher than if they're listening just over speakers. So if you're watching this lecture with speakers, you should get on headphones, the same way your students are going to be listening to you, and get the same experience that they're getting, so you really can kind of perceive, the issues that they might be dealing with. All right, so let's see a comparison here of those things. Advance the slide. All right, so this is a side-by-side comparison of two different lavalier microphones. One's just a cheap one that came with something else I bought, and then this is one I bought separately. I think this one I would guess would be like a $10 lavalier microphone, and then this is a $30 lavalier microphone. So right now what you're listening to is the $30 lavalier microphone, and I'm going to plug in the other one here right now. All right, now we're listening to the cheaper microphone. All right, so we're doing an audio quality check 1 2 1 2. And hopefully that sounds a little bit different than the other one. Again, they're both relatively cheap microphones. This one, I would guess, they're around $10. The other one around $30. All right, so hopefully you could see the difference between those two things. So let me go forward here. Oops. All right, so here's another video showing you again a different price point difference and different style of microphone difference in this case as well. All right, so now we are recording using the $30 lavalier microphone. I have it side by side with my studio recording microphone. So right now we're listening to the cheap lavalier microphone, and I'm going to switch over here. Now we're on the more expensive microphone. So you can see the audio quality comparison between a $700 microphone, and now I'm going to switch back, and that of a $30 microphone. All right, so that's the microphone I'm using now. So I probably didn't need to demonstrate that comparison. But all right, so the other thing is that when we're talking about the recording equipment quality, we're plugging a microphone just into the jack in our computer. So those lavalier microphones are literally just plugged straight into my computer, which means it's plugged into the motherboard. And so I have a professional motherboard, so I actually have really good, straight, jack for my 3.5 millimeter, but your computer may not, depending on what type of device you have. So, you can buy a little external audio card. They're $7 on Amazon, somewhere thereabouts, anywhere from $5 to $10. But you get a little USB plug thing, and it converts it straight to a digital signal then, and so you have less electronic interference. So if you're getting a little bit of buzzing in the background, that might be something to try. It's a minimal expense to try out a USB audio card. What I would highly recommend if you plan on doing any, amount of online education for any duration of time is investing in something, a professional recording device. I use a Zoom H1N. That's the one most people use. Is kind of the industry standard. And so this one is a dedicated professional audio device. So you can plug in your microphone into that device and then plug that device in your computer with a USB cable. So the conversion from the microphone to a digital signal is in a professional audio device, and you won't get, any interference from the recording equipment. Of course, this microphone I have plugged into a professional preamp, so I don't deal with that. But you could potentially really improve your audio quality by using something like that. That Zoom H1N is like $130. You can get a used one, quite a bit cheaper because these things are so common that people are, getting rid of them all the time. So recording equipment quality matters. If you're plugging straight into your computer, that's fine. Maybe a USB adapter would be a little bit better, or plugging into a, professional audio equipment, Zoom recorder would probably be the best option. All right, so bit rate and sample rate, if you really get deep into audio, they matter. Usually we don't have control over that, and even if we do, it doesn't make a huge difference as long as we're somewhere within reason, which if you just leave, device settings default, you are. All right, so now going on to video file sizes. So video file sizes can really matter if you're bandwidth restricted, right? If a student has to download a 10 megabyte file versus a 300 megabyte file, that can be vastly different impact on how they get educated. And so the things that contribute to video file size are these three things: the bit rate that the video is recorded at, the frame rate the video is recorded at, and then the resolution of the video. So if we look at this picture of me and my family, that picture is composed of individual pixels. Those pixels are essentially what we're referring to as bits. They can be high quality, ones with very, with a high amount of detail, or they can be low quality. And so if we look at these two things, these two identical pictures, the same size, right? The XY axis here for these two is identical, right? I sized them to be the same in Photoshop. One of them has a higher amount of information, doesn't it? So the picture on the right here, much more clear of my face and the rest of my family than the picture on the left. And so these images would have different amounts of data contained within them. This one is grouping pixels to reduce the amount of data within the image so that it could be a smaller file size. So that would be a lower bit rate in video. So, if you have a lower bit rate video, if you push it far enough, you may get into the realm where your video looks like that image on the left. And if you have a higher bit rate video, then you're going to be pushing more towards that image on the right. And so the key is to find the balance of necessity and file size and quality, right? So you want, of course, the highest quality for the lowest file size that you can achieve. And, depending on what you're doing, what type of content you're delivering, that may matter more or less. If I'm just giving a straight up text like PowerPoint, I could probably push that bit rate as nearly as low as my computer will allow me, and it's going to be totally acceptable as long as I have decent audio quality, because that's the most important thing. So this is just a much smaller picture essentially that's been scaled up. And so you can't tell the quality size, when it's smaller like that. And so essentially, with a lower bit rate, you're just taking a physically smaller image and making it whatever dimension you have pre-specified. So what affects bit rate? If you're streaming video, your bandwidth is going to impact it. So I think everyone hopefully has had the experience where they're streaming a video and it looks really grainy and crappy, and then maybe your bandwidth improves, for whatever reason, and now all of a sudden your video looks clear, or it scales up the resolution or something like that. Okay, so bandwidth plays a huge role in the bit rate that the video is being displayed to you when you're streaming video. When you're recording video, when it's on your end, what control do you have over bit rate? Well, a big part of that's going to be the rendering power of your computer. Some softwares will just look at the power of your computer and kind of decide what the best bit rate is to download that at. If you're rendering it in the cloud, they may downgrade your bit rate just to improve download time and those types of things. So the same thing that we're considering. But if you're recording in a free software like OBS, which is what I'm using right now, you can manually specify what you want that bit rate to be. So if I want higher quality, I'll go higher bit rate. If I don't care so much, I'll push it down lower just to reduce file size. Look in your software and look at your recording settings and see if you can control the bit rate. And you can push that, see where you can push that to maintain the quality that you need for whatever you're doing while still maintaining a low file size. All right, so what bit rate would I say is ideal? Well, for a general lecture recording, I would say anywhere from 1 to 2,000 kilobytes per second is totally fine, right? Or 1 to 2 kilobytes per second, 1 to 2,000 bytes per second. That I think is the best balance between maintaining something that's really highly watchable for quality, but then also maintaining a low file size. If you know that your audience has good bandwidth for downloading your video and those types of things reliably, then I would say 3,000 kilobytes per second is really past that. You're not going to see a perceptible increase in quality. So anything more than that's kind of wasted. So that's the maximum quality for people with high bandwidth that I would say is necessary. And then frames per second, right? So your video has to be 24 frames per second or higher to be considered a smooth video to the human eye. Anything less than that's going to start looking a little bit choppy. I'm shooting this right now at 30 frames per second. But if you're just doing a PowerPoint and you're not, having anything moving, you could push it down to even 5 if your software allows it. I think OBS only allows me to go down to 10 frames per second, but I have a few other screen recording softwares that I'll use, and I can push it really low. And of course, if you have 30 seconds of video with 30 frames per second versus 30 seconds of video with 5 frames per second, that's a huge amount of data that you've just trimmed off, right? I don't know what 5 divided by 30 is, but whatever that percentage is, it's going to be quite a bit smaller file size because you've just crammed less frames into that video. All right, so I'm going to show you a few different comparisons here of different length videos and the size that video ended up being. All right, so this is a video test at 300 kilobytes per second bitrate and 10 frames per second. So I've reduced both the bitrate and the frames to reduce file size. Because this is a video where I'm moving, the 10 frames per second is going to be a bit of an issue. If this were a PowerPoint that I was narrating, 10 frames per second would be unnoticeable, but the low bitrate is going to really sacrifice image quality. It's going to look very pixelated. I've also reduced the audio bitrate a bit, but that tends to not have as much effect as sampling rate, and I can't alter the sampling rate in the software, so the audio should sound similar between this and the subsequent video. All right, so I'm going to come back on here and switch slides to the next one, where I've got a video here now. It's a bit shorter, and you'll notice it's quite a bit larger file size, even though it's shorter video, but the quality, of course, is going to be different. All right, now this video is going to have a higher bit rate. I'm using 3,000 kilobytes per second now instead of 300, and I'm using 30 frames per second instead of 10 frames per second. So if I move around a bit, it's going to be much smoother, and it shouldn't be pixelated because I have a high enough bit rate. I've also increased the audio bit rate from 64 to 256, but because I'm using a low quality microphone, they should be fairly indistinguishable audio quality. All right, so let's try to advance the next slide. All right, so hopefully you saw the difference there between, those settings. So I altered the bit rate, frame rate, those two things, maybe within your control. You just have to look in whatever software you're using and see if you can configure those for whatever you're doing to maximize the audio quality, if possible, to whatever your needs are. If you might say, well, I've maximized my bit rate and done all these other things, but somehow my video is still, that looks like it's getting a little loud. Somehow my video is still looking grainy. Why is that? Well, you probably don't have enough light on you as a person. So, your camera also has its own settings, and I don't want to get too deep into the properties of the camera settings, but suffice to say, cameras need light, right? That's what they're capturing. So if there's not enough light, of course, it's going to look grainy. That setting is called ISO, and that's usually going to be automatically controlled by your camera. So if you just put more light on your scene, it should correct it. So I'll show you another video, 2 videos here comparing these 2 things. Let me turn off my camera and my sound. All right, this is a video with low light, so my camera is going to increase its ISO to try and compensate for the low light, which is going to make the video somewhat pixelated and low quality, even though my settings for recording may be high quality. All right, I've added a bit of light to my video now, and my camera has adjusted its ISO down, so my image quality should be much higher, simply due to the fact that I've added more light to the scene, even though none of my recording properties have changed. All right, let me get out of this. Okay, so now I just want to show a summary video kind of comparing, different videos with all of those properties combined into one to show the difference between an overall low quality experience and a high quality experience. All right, so this is just a summary now showing a combination of low audio quality and low video quality. It's got a lot of static. It's not easy to watch because it's choppy, it's grainy, and this is how a lot of the videos come through if you really just kind of sign up and go with whatever built-in stuff is in your system. And I want to compare with this, which just has a little bit of optimization. Okay, so the microphone is closer to me. I've moved it up closer to my mouth so that it's a little bit higher audio quality. I've moved my lighting around, so instead of being behind me, it's in front of me, lighting me up, which improves my camera settings. I've improved my recording settings a little bit. And so you can see how the combination of a few different things, all using the exact same low budget equipment, can really improve your lecture watchability. And that will also improve, not only people's perception of the quality of your education, but also their actual understanding of what you're saying, just because it's easier to engage with what you're doing. Going back to the low quality recording again here. All right, and now we're back to a high quality recording, showing what it looks like with optimized settings. All right, and one more time, just back to the low quality recording. All right, and finishing once again on a high quality recording. All right, so I'm coming back on here. All right, so hopefully that gives you, a little bit of insight into how you might create a high quality, educational experience with hopefully not too much effort. If you found that helpful, smash that like button, share it, and let me know if there's any other content you'd like to see on my YouTube channel in the future.